are you? So in today's session, we are going to talk about the time series analysis, and we going to do some time series analysis on the data set and do some perform some operations, draw some graph on that. So let's start with it. Understanding the statement and the dataset. First, we are provided with the time series problem involving prediction of numbers of computers of jet rail, a new high-speed rail service by Unicorn investors, and then we are provided with 2 years of data, August 2012 to September 2014, and using this data we have to forecast the number of computers for next 7 months. So that is our problem statement and is our that is our data set. So next we are moving to the graphs or the plots which we are going to draw in our session, so that we could predict something like the sales in the next few 7 months. So first of all is moving averages. We can infer from the graph that the prices of coin increased some time periods ago by a big margin, but now they are stable. Many a times we are provided with a data set in which the prices sales of the object decreased sharply time periods ago. In order to use the previous average method, we have to use mean of all the previous data, but using all the previous data doesn't sound right. Using the prices of initial period would highly affect the forecast of the next period. Therefore, as an improvement over simple average, we will take the average of the prices for the last few time periods only. Obviously, the thinking here is that the recent value matters. Such forecasting techniques, which uses window of time period of calculating the average, is called as moving average techniques. So basically, the moving average techniques is means that when you have the 10 series of data and you take the window of three, then you take the average of first three, then the take the average of second three, second, third, fourth, then the take the average of another three, three, four, five, then the take of another three and another three, so like something like that. This moving averages is work, and you are calculating the averages using a window. Next is calculation of moving average involves what is sometimes called a sliding window of size n. Using a simple moving average model, we forecast the next values in a time series based on the average of a fixed finite number p of the previous value. Thus, for all I is greater than p. So basically, yi equals to 1 upon yp, yi minus 1 plus yi minus 2 plus yi minus 3 dot till yi minus p. This is the formula for the moving averages. And now this is what about a moving averages is look like. We have a train data, we have a test data, and this is the moving averages of the data. Like this is the average of all the data, these points. And next is we can see that the knife method outperforms both average method and the moving average method for this dataset. Now we will look at the simple exponential smoothing method and see how it performs. An advancement over moving average is method is weight moving average method. In the moving average method, as seen above, we equally weight the uh, past and observations, but we might encounter situations where each of the observations from the past and impacts the forecast in different way. Such a technique weights weighs the past observations different is called as weighted moving average techniques. And it is something like where a weighted moving average is moving average where within the sliding window values are given different weights typically, so that more recent points matter more. Instead of selecting a window size, it requires a list of weights which should add it up to one. For example, if we pick 0.40, 0.25, 0.20, and 0.15 as weights, we would be giving 40%, 20%, 25%, sorry, 40%, 25%, 20%, and the 15% to the last 4 points respectively, something like that. We provide some weights for these values of the a window of n numbers, then it is called as the weighted moving averages. Next, simple exponential smoothing. After we have understood the above methods, we can note that both simple average and weighted moving average lie on completely opposite ends. So basically, as we see that the simple moving averages and the weighted moving averages lie on the completely opposite side, we would need something between these two extremes approaches which takes into account all the data while weighing the data points differently. For example, it may be sensible to attach larger weights to the more recent observations than to the observations from the distance past. So basically, we are giving the large weights for the nearer observation, new observation, and giving the less weight for the past observation. The technique which works on this principle is called as simple exponential smoothing, and forecasts are calculated using weights averages where the weights decrease exponentially as observations come from further in the past. The smallest weights are associated with the older observation, and its formula is something like this: y hat t plus 1 divided and slash t equals to alpha yt plus alpha 1 minus alpha yt minus 1 plus alpha into 1 minus alpha square t minus 2 till n number of times, where alpha is lie between the 0 and 1 and can be also equals to 0 and 1 is the smoothing parameter, that how much you want to smooth it. The one step ahead forecast for time t plus 1 is the weighted average of all the observations in the series is y1 till yt. The rate at which the weights decrease is controlled by the parameter alpha. This parameter alpha this parameter alpha controls the weight, and it makes the weights decreases as we move on, and make the previous weights smaller, and the makes the newer weights makes for the current value the weights becomes the larger, and for the past value for the past more values, the last values, it makes the weights less value. If you stare at it just long enough, you will see that the expected value y hat x is the sum of two products alpha yt and the 1 minus alpha yt minus 1. Next is, hence it can also be written as y hat t plus 1 slash t equals to alpha into yt plus 1 minus alpha into y hat t slash t minus 1. So essentially, we have got a weighted moving average with two weights alpha and 1 minus alpha. As we can see, 1 minus alpha is multiplied by the previous expected value y hat x minus 1, which makes the expression recursive, and this is why this method is called exponential. The forecast at time t plus 1 is equal to a weighted average between the most recent observation yt and the most recent forecast y hat t slash t minus 1. And this is about the this averages where we have train test and this average, which is simple exponential smoothing, SES, which is looks in this which represent by this line, green line. And that's all about this theoretical session where we talk about the time series analysis, understanding the problem statement and the data set. Then we talk about the moving averages, how it's look like, and then we talk about the simple exponential smoothing and some formulas about it and how it's look like. And now we move on to the coding session.